Welcome to the 2012 Institute of Navigation Autonomous Snowplow Competition. 6 teams are competing this year from a variety of recognized institutions, and they all share passions in science, technology, engineering, mathematics, and navigation. We're going to take you back now 2 days to the beginning of this competition and show you a sample of the technical presentations each team gave to our panel of industry professionals.
He currently designs guidance and navigation control systems for Honeywell's global applications. Bibor?
On behalf of the ION Snowplow Committee and Sunil and myself and the rest of the committee, thank you once again for coming.
Hi, I'd like to welcome everybody on behalf of the ION. We're very pleased to have the 2nd annual snowplow competition here.
It's very exciting to see all the young scientists in the audience and see the progress that's being made on exciting new innovations.
And here are 4 of my teammates, Yue Zhangzhou,
Yeah, that's me.
and Taoran Yan, Yumian Wang, Jia Huang. So thank you for the cooperation with me. Okay, so let's start the presentation.
And the third part is the design. It includes mechanical design and the system design. And the last part is the drawback analysis.
First of all, we initialize everything like vision, camera, and encoder.
And then we set half of the width to the right of that point so that we can find direct targets.
PLCs and sensors, we got those off of a donation, so that was really good and really cost effective for us. That helped us out. On the backs of those, opposite of the wheel, we do have 2 optical incremental encoders that allows us to close loop. We have a 3-way emergency stop system. We have the physical e-stop that's mounting on the tower that kind of comes off at an angle in the rear of the machine. We have the wireless key fob. And then we also have a watchdog timer that would go ahead and shut everything down. If any 2 of the components lost communication with each other, it would shut it down.
We use a vision-based navigation system. We just used a regular webcam that you can buy at any store.
The traction system takes into account the weight, friction, as well as tire radius, and the traction control system.
We generate these masks when we're initializing our vision. They're in order from the farthest left path. It gives the robot to the farthest right, giving the robot 9 paths to choose from.
In addition, we can also reduce the friction by adding wax to the face of the plow.
And we're the Blizzard Buster team from the U of M. The whole thing's powered by 2 servo motors for each driving wheel. They give us angular position feedback for speed control. Thermal control and structures, or TCS, and guidance, navigation, and control, or GNC.
Thermal conductivity, and we chose the one that has very low thermal conductivity. The heat loss would be around 10 to 20%.
First, we want a very fine position accuracy, about 5 centimeters. We achieve this with the Topcon Hyperlight Plus real-time kinematic GPS system.
Basically T-slotted aluminum, so it's basically like big kit erector sets. You can just slide in and out parts, cut them to the exact lengths that you need.
Our augmentation system is our RTK DGPS system.
We're constantly pulling our IMU, our GPS, our wheel encoders. So if we detect that we're slipping, we're just going to give it more power.
carrier phase-based tracking, which is very fragile, and especially when you have multipath in an urban environment, we do see not the loss of satellites, but the loss of the carrier phase lock.
We can give threads priority and processes priority if we needed to.
And it's really given us a great opportunity to both push ourselves to learn more, and it's just been a great experience all the way around.
And this plow will move with the speed of 1.5 meters per second, so which means we can finish the whole plowing within 1 minute and get the maximum bonus point for time.
We are using a SICK 360 laser scanner. It scans at 5 Hz with a maximum range of 250 degrees.
The switch triggers 2 timeout counters, which are output from a 74-123 chip.
These modifications include new and additional encoders on all 4 motors in combination with motor current feedback. Our software design centers around a single 2.4 gigahertz quad-core processor with a solid-state hard drive.
You were there last year, and I was just wondering how reliable or unreliable the GPS is at the test site.
I think I heard that's like a dead man switch that you has to be engaged, otherwise it stops it. Is that true or not true?
What did you come up with for an angle, and what were the trade-offs for going with less of an angle or more of an angle?
I was wondering if you had any trouble with controlling the system as it crossed from one threshold to the other, if you applied hysteresis, or how you handled that situation.
You said you built your own real-time computing platform. Did I gather that correctly? The running Linux?
This coronal mass ejection that took place recently, where you have this huge sunspot activity, do you anticipate that could cause an impact on your GPS system? And if so, can you then switch over to your backup mode?
The on-field competition started early Saturday morning with each team attempting to first clear the I field, a 10-meter-long straight run. And today, each team attempts the U field, which adds 2 90-degree turns. Let's take a look at how the competition went and talk to a few members of the teams.
And it's off.
These guys, this was not a project they got a grade for, that they got credits for. I know Corey and Joel, there was nights that they spent here till, at the school till 10 o'clock at night working on this thing. So it's an extracurricular activity that involved literally hundreds of extracurricular hours and a chance to really showcase their hands-on skills.
Good job by the Snow Devils. 2.
Well, tomorrow's a whole different beast. I'm hoping we can do the same thing. It's pretty much the same corner twice with a couple of straightaways in between it. So we're going to use the same program we used earlier today on the I course, and we're hoping for a similar result, if not better.
They actually picked up Visual Basic kind of on the fly. If they're programming in a programmable logic controller, they can pick that up no problem and just run with it. Or if they're working with an industrial articulated robot arm, they could work with that no problem. But this is a totally different look and feel compared to the skills that they're learning at Dunwoody.
You think it'd be easy to make an idea?
Where's your key guy? Oh, careful.
Let it go, guys. We'll push through.
Restart. You are going to do a restart?
Hold on, guys. Think about this before you guys do it. Let's think about this. Restart options. We can either restart right where we're at, or go back.
No, the restart, you go back.
We got to go all the way back. I don't think that benefits us at all.
No, I think it does. Let's restart it.
What are you going to do?
We're going to adjust the contrast. It's the lighting that got us.
SpaceX, the Toro company.
Okay, they're done. They've decided to...
Cool.
So Dunwoody is called their run.
We're actually a 2-year technical college, so we really pride ourselves on hands-on learning. So you'll see team members here from our automation robotics, from our engineering drafting design program. We got team members from machine tool and welding. So this project really allows them to put all of their skills to use.
All right, why working magic?
100 milliseconds. 200 milliseconds.
200 speed, yeah.
3, 2, 1. You can begin your run.
These students were students that were in the mechanical engineering program. They're all seniors, and before they graduate, they have to take a class which is called the Capstone Senior Design class, where they learn how to design a product from end to end.
Then their machine's going to have to
Back.
scan.
No, so what are the penalties for restarting?
It's 10%.
10%?
But you've only done 20 of it already, so...
10% over 20? Or 10% of all? Yeah, I see what you're saying. Yeah.
No,
it would be better to restart.
2, 1. Minnesota, your time is up.
Kill it.
For some, it's the first time they actually get to design a real live engineering product. And it's a world of difference learning about things in book and actually trying to put something that works.
Why is it just stopping like that?
Because the right motor isn't moving any.
Yeah.
And so I have a reset button where if the speed's 0, then it goes into this reset loop.
Okay, so they're going to declare a restart.
Like they're declaring a restart.
It's got power. It's got power because the light's on, so it's everything from here on.
Yeah, you might be able to do that.
You only got a few minutes, so you got to make your best decision.
Wait a second. I mean, even though the plow they designed didn't complete the course, I'm pretty sure they learned a lot of things of how much harder it is to design and build things that actually work in real life. So.
Are you ready?
I think we're about ready, yeah.
Okay.
Oh, here we go! Go, Red Cloud! Ridley! Being judged on how long it takes and how much snow is removed. Way to go, Miami! 3, 2, 1. Your run can begin. And we're off. They will be judged on how much snow is removed from each 1 meter square. Here comes that first 90-degree turn. That's a nice turn.
Are you choosing to do a restart?
We're asking if we choose to do restart.
If you choose to restart, you're going back to the beginning.
Does anybody have a problem need solving? We've got a lot of engineers here. Oh, it is plowing like a maniac.
We're the only team using the GPS system, so that's kind of unique in that we have a disadvantage that we're in this urban environment, but we've also learned to correct or have some backup plans to help us in case that doesn't turn out. We learn about everything from rapid prototyping of building materials to actually going out and testing and breaking things.
Coming into some more challenging terrain.
Yeah, can we pull it back so we can do the judging?
Well, one of our main concerns was that we couldn't provide enough power to the ground to actually plow the snow. We'd have too much of a snow load. We never had any snow in Ohio, so the navigation solution was our primary focus once we had the mechanical platform built. So we had plenty of time to drive all the bugs out of that.
Guys, all ready? Zach, Doris.
4, 3, 2, 1. Begin your run. And now they'll be placing into the field.
Zach, check the line up on that side.
Here it goes.
Oh, great. We need to recycle the power. The motor on it crashed from all the water splashing.
Okay, let's restart.
We don't have a choice but to
Do you want
restart.
to declare a restart? What you mean is you stop and then bring it back here and you're going to lose up some points, but otherwise you're going to...
We don't have a choice. We have to.
You restart, okay.
Yep.
Fine, that's fine.
We have to use push.
All right, now put this on the split.
That's pretty good.
Slap the snow out of bed.
You won't lose that much, don't worry. You can clear the snow, it's not going to matter. It's not meant to penalize you that much.
this is a team spirit. I mean, what's the most important thing they get out of this is the team spirit. They know no one person is going to be able to do this. So it means that they need the entire team working as a team. So why did it stop?
I don't know why. I think it ran out of cones. I don't know why. Can we just restart?
Oh yeah. Okay. Restart.
Take a new restart.
Take a restart.
I'm sorry. I'm not moving. Come on, Eddie. Yeah. Go.
Oh, you're not
We're done anyway.
Yeah.
So.
What you learn in the book gives them the theory that tells them why things work the way they do. But until they come and actually do it in practice, it's all, math and calculus and engineering. I mean, engineering is not something they touch and feel like they do here. And this competition really brings out the best. This year I was lucky to get about 8 exchange students from China. They all came in September, so they joined the club, and I said, hey, here's the competition, you want to come? And they didn't know what they were signing up for. It's a unique opportunity for them.
Just move to that side of it.
Where are we going?
Hey!
What?
That's motor. That's motor. That's motor. Don't. Oh, yeah. It's good.
Perfect. Yeah.
Go, 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 go. 走啊
We confirmed that their nav was different.
王一萌，有一个歪了。3, 2, 1, go. Come on,
They're
guys.
being judged on how much snow they remove and how
What?
fast they do it. And they're doing it at a fair clip.
Well done. Well done. Hopefully. Come on! Yeah, that's it. That's it. Yeah, okay.
Engage. They're placing the navigation beacons. They're applying the rainwater solution for the traction control.
Go. Get out, you!
Out and we're off. Come on, Haley! Good progress. And for the blue, making up the orange. Here comes that first turn.
You think it's the software just confused?
It doesn't. You can't really tell what it's trying to do because it's obviously moving. I don't think it's stuck.
If only we knew what it was thinking right now.
You want to stop?
Our water's done, so we have no more water.
2.0. That will do our final run.
And I really thank ION for what they're doing. I mean, it's really great for the students too.
1, 2, 3, go!
We're good.
We use a 360-degree scanning laser.
All beacons are set. Initializing in process.
3, 2, 1, go!
It's still harder. You see it kind of wobbling like that?
Backing up, getting ready to initiate the turn. It's very smooth. Corner 2. Twice the snow on this side. Let's see how it goes.
I'd like to thank the Roseville Ice Arena for all of the Zamboni shavings. That's our snow today.
Oh, look at it. It's just coming up in chunks.
And if you look at the forces involved, it's enormous. Like we have a 5 horsepower system. We consume over 5 kilowatts of power when we plow.
So it's quite a challenge to control that huge amount of power and have that razor sharp straight line. So a lot of fun too. We know within about an inch where the robot is at all time, and that allows us to maneuver very precisely.
It's programmed to go slower around the corners than it speeds up on the straights.
Are you going again?
No, we're going again.
We're going one more time.
Okay.
First run was at 1 meter per second. This run we're going at 1.5 meters a second. Reach the finishing zone. It's going to turn around now, do one final pass back to the starting zone, and then call it a day.
Now, all of our students are electrical engineers, and so there are 2 undergraduates, and then we have 2 PhD students. It really gives them a real-world experience. They get to go through the whole design, all the testing. They get all the experience of writing design reports.
You tell us when. Stop.
And that's it. Time out.
6 minutes.
5 minutes,
6
45
total.
seconds, rounded up to 6 minutes.
Oh man. Congratulations. Good job, you guys. Very good, very good, very good. What happened in the beginning? Do we have a computer hiccup?
Wireless wouldn't connect.
The classroom experience is part of that, but then going out in the field and getting real-life experience is really what puts it all together for them.
They are judged by very experienced people from the field, and it's a great honor actually to have to present for some of the top people in the field and just get their take on what your design is and take that into account for next year. So it's great.
This event is made possible by all our volunteers and sponsors. Thank you for all your contributions. As you can see, your help is certainly developing student skills in science, engineering, math, and navigation. Let's listen to what a few of our sponsors have to say.
Education of students, from being involved in intern programs, those kinds of things are important to us. They ultimately are our future employees.
We have interns that come work for us, and of course we'd like them to work for us when they're done, but that's not a requirement. They can come work for us for 4 years while they're going to University of Minnesota or University of Wisconsin or wherever they go to, and then when they graduate they can go into any field they want, and we hope that they've helped us and we've helped them.
As fun as this is, it's also very serious. To us, we need to maintain a pipeline of talent. And for our research purposes, keeping an eye on the progress of students at some of the top universities is very important. And these interactions allow us to stay engaged with the professors at those universities, watch the students, learn how they're doing not only with the technology but in the development of talent for our future scientist base.
In some of the aerospace community, we're pretty well known, but in a lot of the computer engineering, computer science, and electrical engineering, we're not as big of a company or not as well known. So trying to get our name out more so that some of the top talent, like the people competing here, are going to be interested in coming to SpaceX and doing this on the bigger scale and professionally.
We work with GPS, with inertial systems, with very similar systems they're using on some of these vehicles, cameras, LiDARs. We do dead reckoning systems for people, personal navigation, Doppler velocity sensors. We're developing systems for soldiers, emergency responders. Some teams are using GPS, but some are using other forms like the LiDARs, cameras, and we're very interested in that technology.
The 3 teams that are running right now that do vision processing use very inexpensive internet webcams for their sensor technology for navigation, which is something we're attracted to because we want to develop a vehicle that's very practical yet commercially inexpensive.
So our first award that we're going to hand out is the Golden Shovel Award. That was for the best student presentation. And that award goes to Ohio University. So we would like to award the Golden Pen Award, to Ohio University. The University of Minnesota, 6th place. Come on up, Minnesota. 5th place overall award is to another hometown favorite, Dunwoody College of Technology. Goes out to University of Michigan Dearborn, Team Gailey. 4th place. Congratulations. Team Yeti 2.0, the University of Michigan Dearborn. 3rd place, $1,000. And the bronze globe. Miami University, 2nd place. Congratulations. The winner of the $2,000 prize. And there were 2 teams that stood out very much about who should get the Golden Smile Award for Best Sports Sportsmanship. And Ohio University did a very nice job. But we're going to be awarding it to Dunwoody College of Technology. Nice work, Dunwoody.
$500 is another Robotech controller.
So we would like to congratulate Ohio University for the 1st place. 2nd autonomous competition, and second time in a row. Congratulations, Ohio University. $3,000 prize winners. Excuse me.
Put this down a little.